Yeah, so if you
That's
have
hard to imagine. How
Well,
does that even?
That's important
hold on.
key right here.
Oh wow. I did high voltage experiments when it comes with light, right? And the more amps, the more whiter it gets. But then the less amps, it goes into yellow, and then we get into a reddish stage, and then we go into like a purple stage when it gets to the barely can run. But if I put like a laser or something on it, that's I'm curious to see if it changes the color at that point from what I had. Like is if that's one magnetic field in the laser versus another magnetic field of the experiment, you know what I mean?
Well, every
You're
color
thinking it
has
might
its own
alter the
frequency,
light?
though.
Yeah.
Well, because
Every
I'm
color
adding
has
more heat to that one area, not all of it.
Every color has a unique
As a
frequency.
color and a frequency.
Like red and blue are different frequencies. Yellow's a different frequency. Green, different.
No,
frequency.
I understand that. I
Yeah,
understand
red is hydrogen and blue is oxygen.
I don't know the frequencies, but I know they're different. You know.
Yeah, but well, yeah, the frequency, the frequencies are different, but you're assuming that the frequency of the electric field is the same as the magnetic field. But what happens when the electric field has a different frequency from the magnetic field?
How do you do that, though? I mean, how do you actually do
Yeah,
that?
I've never seen that.
Yeah, that's
Yeah,
How would you
find
actually
it in fusion.
produce that?
well, you just
See what time it is. One.
you use a capacitor and you add a magnetic field next to it or something like that, and I mean it's gonna create
Yeah. I mean, those kind of events. I'm not saying they can't happen. I don't think man's able to do it, though. It might be in space going on, you know, things like that. But we have to send our electric out at a frequency to get the magnetic to function, to even become a magnetic. It has to be transmitted at a frequency, and that magnetic will be created at that frequency. If I'm pretty sure.
Yeah.
Would it make a difference if it's in a vacuum sealed chamber to conduct this experiment? Would you be able, would it make a difference?
I know
In space.
the volts are ahead of the amps by 90 degrees. Is that correct, Mike? Like the volts are 90 degrees ahead of the amps.
Oh, are you talking like a magnetic wave? Is that what you're going with, Mike?
Yeah, because the amps will make the magnetic, but the volts won't. Well, the volts will, but not until the amps catch up.
Yeah, so as one thins, the other one thickens in a 90-degree angle. Yes, that's
It takes
what you're
90
asking.
degrees for the amps to catch up to the volts.
But that's just the way we see it. I don't know if it's 100% 90 degrees or if it's off a little. You know what I mean? I'm just saying that's how we always picture it.
It's around there, 90 or so.
So what exactly are we seeing in space when the amps like get thicker? Is that's what we're observing? If one needs to catch up to the other.
When you know that the amps are lagging the volts, it tells you the volts is obviously more impactful than the amps because the volts is transmitted first. It's ahead of the amps. The volts is the first signal to get to the other end of the coil. The amps is 90 degrees behind it, which is rather quick in time reference, but it's still measurable.
So the more heat you have in your system, the slower the voltage gets there, is what you're saying. And we don't detect it in what we do, but for other things, yeah.
If you have enough volts to get across whatever resistance, it will get across there I think, faster than the speed of light, because it's not light. It's a pressure wave. It's a pressure wave. It's pressure. It's potential. It's a potential wave. And then the current is transmitted with the volts, but it's 90 degrees behind it, which once you know that, you kind of got to keep thinking about that. Tells you that the volts has got more impact than the amps overall. universally, since it's able to transmit through the coil before the amps.
So one is speed, one is pressure.
Right. Well, one is current, or one is flow, not necessarily travel or distance, but flow, as you know, like the river flows, or like a circular flow, the revolutions per second. Yeah, speed, right? RPMs. So the more amps, the more flow, RPMs per second you're generating. But the volts is just there to get those cycles, those RPMs across the other side of whatever inductor or resistive path there is, which yeah. I mean, if you
Like,
had
if we're
sorry.
talking about electricity, we're talking about like a linear line, and it just depends on the thickness of the wire. So if the
Well,
thinner,
it's vibration,
thick,
so lines don't matter, curves don't
right?
matter, angles don't matter. It's vibration. It's a vibration. The frequency is a vibration, so it's going to propagate through any geometry, through the vibration. Not because it doesn't have to go in a straight line. It's a vibration.
So I think there or a
Of when you guys are talking, how the solar system propagates through space. You've got the sun in the middle, and then the planets all around, but they still, go around while the sun is moving. Like and it sounds like if you've got that energy in the middle, but everything else is, going around to, like all in one unit. You know, I don't know if that makes sense, but if you've seen the video of how the solar system moves through space, and it does that whole helix, it almost sounds like what you guys are describing, but we're talking on a cosmic scale.
Absolutely, Lulu. And it's, I believe, Nassim Haramine's model that you're referring to of it, and it's like the
Yeah.
DNA spiral helix of the Earth, the Moon, around the Sun, around the center of the galaxy. It's wild.
Yeah, like I saw this. Yeah, I mean, just we're like.
it's like killing my hearing aids right now.
Yeah.
What is it?
Huh,
Bernie,
Bernie,
you got to echo.
he's not near his mic, so it's like it's digging into my hearing aids when he talks. It's got like a weird sound in it.
Yeah, you sound a little buzzy tonight, Murray.
My apologies. Is this a little better, or hold on?
Yeah, that's better.
A little.
Sorry,
Yeah,
I had Ashton Forbes on in the background. That's why. My bad.
Yeah, my
My
computer's.
bad.
My
Right?
computer's
Free
off
Energy
now.
Fridays. We got to get Ashton on.
Yeah. Well, my computer is off right now because it's giving me nothing but trouble. So I'm actually running the whole show from a cell phone.
Oh, nice.
I always use
Yeah.
a cell phone. It works.
The CIA is not gonna get you alive.
Oh, really?
Yeah,
I
we
don't
got
know.
your number.
Helping you co-host.
Yeah, so
Is it
so
something you're gonna
I put
publish?
in the chat the measurement unit of the electric field and the magnetic field, and you can see kilogram. You have the in the numerator. You have kilogram. In the denominator, you have coulomb. I put a double letter, so it should be one C and one M and one S. But
I don't even know what a coulomb
I
is.
put a double letters because otherwise my math tool is going to confuse them with variables. So these are measurement units, but you can see it's kilogram per coulomb. The magnetic field B is kilogram per coulomb times frequency. Same thing with electric field. It's kilogram per coulomb times frequency times speed of light. So you have a frequency on both of them.
Can I put those in the public chat, or you want them staying in private?
No, put them in the public chat.
I guess distinguishing between an electric field and a magnetic field is hard to do. eyes, they're the same, one and the same.
It's the same thing. You just add the speed of light for the electric field. It's very simple.
I mean, isn't the magnetic field and the electric field, isn't that the same thing, though?
Well, they are a part of the same thing, because the second you put like biggest discovery. So
What, wirelessly? Maybe.
yeah, well, it's longitudinal. It's basically like an impulse wave. That's what Tesla calls it.
Right, yeah, but
Right.
you're not using material to transmit. You're just going through the air.
Right, exactly. And that's why the the stuff that would slow things down, like say a magnetic field, it will have interference in space to slow it down. That's why the speed of light is basically a magnetic field bending in on itself, which makes light. That's why it's limited to 186,900 uh, feet per second as the speed of light.
Yeah, but a radio
Right.
signal does have a slight magnetic field.
Oh,
Right.
hold on.
But sorry, but Tesla says a longitudinal wave is the speed of light pi over 2. So I seen this one interview he did with Chris Carson, and the guy in the audience says, well, that's exceeding C. And he goes, what's the limit? And Dollar looks at him kind of giggling. He goes, what limit? There is no limit like this. So when you're using a longitudinal wave, the speed of light means absolutely nothing. There is nothing to slow this wave down or this impulse. So that guy in the audience is just like, holy cow, like, it's pi over 2 to the speed of light. So that's like more than double, the speed of light.
That explains the UFOs and how they move so fast, because they're
That's
not
right.
in the light thing. They're in longitudinal wave.
Right, exactly. And that's what,
Right.
the
It
point
displaces
that
the
Dollar was
medium.
making.
That's exactly what I use in my experiment.
Yeah, and that's
So
exactly right.
do you see the
So-
pattern? The pattern in the equation I just added, the electric field.
Yeah, I've seen that.
Cool.
I've seen that.
It's just the magnetic field times the speed of light.
Right.
It's all the same thing.
But if you remove the magnetic field from the equation completely, now you can go way beyond the speed of light because there's no magnetic field involved. And I think that's what Dollard was getting to, what Tesla was talking about. He says, as soon as you remove the magnetic field and go into a longitudinal state, there is no limit. You exceed C.
But
That's
longitudinal
such a-
waves are not going through any copper wire. They're just going through the air.
Well, it's instantaneous propagation. So we could have a conversation with somebody on Mars.
Right.
with
It
no
propagates by
latency.
displacing the medium,
That's right. That's
So
right.
it flips
That's what.
the electrons.
So
No, it pushes the medium
it's an instantaneous propagation.
with each
So that's why.
signal pulse or signal oscillation. It's pushing along.
Isn't it using the hydrogen line? Like the
No,
hydrogen?
it's
Just radio waves.
it's an impulse wave through space. It's like
Just
when you
generating
take
the signal wave.
when you take a rope and you start whipping it up and down like a skipping rope and you see the wave, look at that's Hertzian. So a longitudinal is that same skipping rope held tight, and then one side you give it a little flick and you'll see this
then it'll just
impulse
go
wave
like-
go straight across.
Oh, it's
Right.
like the telephone game with the rope and the
Right, but it's
fan.
being
Right.
done on an antenna, right? It's done on a vertical antenna, though, right?
No, there is an antenna, but there's nothing in between the two.
It's
No, I'm
just
saying they
space.
transmit longitudinal waves on vertical antennas
Yeah.
because then it pushes the medium in
Well,
all
actually,
directions.
they're horizontal. So like a Tesla
horizontal,
coil,
okay.
so like a Tesla coil standing up, but the longitudinal wave's not coming out the side; it's coming out the top.
Oh.
That's why. So I actually done this experiment. So when I take two Tesla coils and I face them towards each other like this, if I put a neon bulb or what do you call fluorescent tube in the middle, when the two longitudinal waves hit that bulb, you would think it would light up. Well, the sides light up, but the middle, where the longitudinal waves are bombarding each other, it cancels out. It disappears. So Dollar says, where's it going? It's going into counter space.
What disappears? What is
When the two waves, the two energy propagations, when they hit each other dead on, they disappear. There's a cancellation of
they
the
cancel
field.
each other. Oh.
They cancel each other out. So you get that dark spot in the middle. You'll have light on either side of the tube, right side.
So
and
they're
left
not in
side of
phase
the tube.
then. If they were in phase, they wouldn't cancel.
Well,
They'd amplify it.
Well,
it's creating like a miniature black hole, right? It's like
yes, it's going into counter space. It's going into counter space.
What is
it's
that?
going into
180 degrees out of phase?
No, he doesn't know. He doesn't know where it's going. He says it cancels out.
Were his two signals in phase?
Of course, they're in phase together. Yeah,
and they still canceled out. They should have amplified.
No, they disappeared. They went into counter space, and this is what Dollard was talking about in his lecture. He says
that's not normal.
No, exactly.
That's correct. That should not. When you have signals that are in phase, they as long as one of the signals is more than one, just a little more than one, you'll have amplification.
And I've actually done this experiment. It does work. I've done it.
So what does CERN do exactly then? Aren't they like smashing two,
they're using electromagnetic coils in a long, hollow circular ring tube to push hydrogen atoms in two directions and smash them into each other at high speed using electromagnetic fields.
Isn't that the same concept, what you're saying? Like they, when the two things meet together, if it's canceling out, like there's nothing.
Now,
shouldn't they be actually smashing and then things, like?
Well, we're talking about hydrogen here, not a wave. Hydrogen is actual matter,
See, they've actually done this experiment wrong. They're using electromagnetic waves to propel the matter. Why not use Tesla's longitudinal wave, having two Tesla coils, one on either side of that toroid, and have that field go around and bombard at a point? Now, what they'll see is now they've exceeded C. If you exceed C, what happens to those particles?
They disappear.
No, I think they actually would disappear.
Yeah,
I think they would switch dimensions. You would lose those particles. If they were to do that experiment in CERN, it would blow their mind. Because of the fact that the basis of how the CERN system works is on electromagnetic acceleration in a high vacuum tube. So they can only go speed of light. That's it. That's why they see all those collisions happen. But if they were to do it with Tesla coils, doing the same thing, but having the longitudinal waves go in opposite directions and then intersect and bombard, I bet you all those particles would go bye-bye. They would vanish.
Mike, you should contact them and give them that idea. You should.
No, we don't want them opening the demon portal fully.
Really? What if the other dimension is a better place? What if it's not a demon place, like you think? What if
Segue, just want to interject.
Utopia.
Sorry, what I was showing there is some red state pink crystal material that I was just able to harvest, that I just produced over the last day here, and it's a very good sample and a pure sample of it. So I'm getting a whole bunch of samples together to start sending all of you some samples to play with and see if you can make these materials do superconducting antigravitic things, right? They make their way disappear.
Yeah. So, you know what? As far as anti-gravity is concerned, I think if you can exceed C, and I think Nathan's in the right direction, totally. if you start using your Tesla coils and point them straight dead on to the gravifier, you might get some interesting effects. Who knows? Like, I'm just shooting an idea out there.
Well,
I don't even know
I'll
if
be
it'll
honest with
actually
you.
work.
They should have put one dead in the center of this thing from the get go. It would have made my life a lot easier, but they didn't do that. Now I have to. Now it comes in and it goes from a longitudinal wave to a transverse wave, and I got to pop it
Right.
back to a longitudinal wave.
Right.
So that's
It's
what the
transverse.
piezo is supposed to do, is pull it back up. So
Yeah.
that might be on purpose. It might not, but it would have been just so much easier for lift just to put it in the center from the beginning. You know what I mean?
Yeah.
It would, my whole life would have been easier. I would have been done with this months ago.
Is transverse the same as Hertzian?
Well, yeah, it's a wave. It's a wave form.
It's horizontal.
Right? It's electromagnetic. All
It's
right.
horizontal wave.
It could be horizontal. It could be sine wave. It's Hertzian. It creates a magnetic field. Okay. A longitudinal wave does
It's a vertical
not.
wave. It's a vertical
It's
wave.
it's a vertical wave that does not create a magnetic field. It
Right.
doesn't exist. And
Oh, you know,
because of
vertically,
that,
vertically, you're going straight up against gravity. Horizontally, you're not. Maybe that has something to do with it.
well, it's just the
The
that
reason
was
why,
Tesla's-
longitudinal does not create a magnetic field. Maybe that's why.
that's what Tesla was emphasizing, the significance of the longitudinal wave, because of the fact that it doesn't create a magnetic wave in the Hertzian form. That's why it can exceed C. There is no limit. It's instantaneous propagation.
Well, see, if you
Dollar-
build Tesla coils long enough, you get the skinny ones, okay?
Right.
And they go cold in the center, so you can always rob their power. When they
Right.
get bigger, now they flow. Now,
Right.
now you're getting the flow that's more in there, so it gets even colder than it's supposed to get.
Right.
That's
And
what
cold
cools
is
down
good.
everything. But that's what also makes it lift. You have to have that.
Mhm.
The problem is the Tesla coil doesn't have enough flow. It's got a little coil here and a long coil here.
Right.
You need
But-
to change the thing. You need to
Right.
change it like this. So if I can create a
Honestly-
Tesla coil that looks like a UFO, I'd be
Right.
sweet.
You know what? I think Tesla made the Tesla coil for a reason, for us in the future to decode it. I
Yeah.
think there's a lot more secrets to the Tesla coil than originally what people thought. Oh yeah, it just makes sparks.
Oh, have you
know
ever
what
you
I
ever
mean?
seen Sean's Tesla coils?
Sean's?
Yeah.
No. Oh yeah, the round one. Yeah, I seen the round one there last week.
Oh, you got to wait till you see the rest of them. He's got these things winding and everything, and they're just like AC flybacks.
Right.
It completely blows the mold round. But then, if he puts a core in the center that's hollow, I mean, he's
Right.
you know what I mean. He can get something totally different than he does with just the pure round shape.
Right.
So he's got a whole different thing going on there, man. And he's only scratched the surface, but it's like way beyond everyone else already.
Have you ever had him on your show yet, or?
Oh yeah, he was on just last week. He presented and everything, and he showed his Tesla coils. Like
Yeah.
I said, though, in talking to him, I know he's way ahead. So,
Hmm.
but that's the next step. I want to get a UFO shaped one. You know what I mean? Where I can get the actual features that I want, because I'm
Right.
not getting it out of the gravity floor like I wanted to, not in the amount that I need. You know what I mean? Because
Yeah.
it drags it down based on some of the other parts of it.
Yeah, the other device that Dollard really talked about, and Dollard's a real cutthroat when it comes to real devices versus fictional devices. Yeah, well, because I've got the free version, it limits
That
me
was-
on certain.
Well, Ben's
things.
streaming it.
Ben can do it because he's got probably the paid version. Right?
I have a paid version too.
No. He's doing it through like another program like OBS
Oh wait, that
Oh,
other thing,
or
Streamlabs or
something
whatever.
else. Yeah.
Oh, okay.
Streamlabs,
All right.
okay.
That's how he's
using
doing it.
Streamlabs, okay.
Yeah, he's not doing it on this.
I'm
Right.
gonna have to do the Streamlabs.
Different plan.
By the way,
different platform.
fantastical frequency equals 1/time, right?
Yes.
When you create it correctly, you're going to get a waveform that goes like this. And we were talking about it before, it's circles, but then take 100 markers and all of them are doing it, right? That's what you're getting, but it's going to expand, right? And when it expands, you're going to get a whole lot of static electricity. If you're standing in that area between the expansion and that, then time change. It's a time dilation.
Yeah.
So it explains the F equals 1 over T. Perfectly. It perfectly explains exactly what's going on.
Yeah. Because like the propagation of static electricity is pi over 2 to the speed of light. So
that's why it's imperative to have in anything that lifts.
That's right. You have to exceed C to get any gravity. I don't care what anybody tells me. It's you have to exceed C. So,
Nathan, I have a question with the Graviflyer.
Yeah,
So it creates a whole big old bubble, right? Like of energy. Is time inside of that area different than time outside of that area?
The problem is it creates it more like a magnetosphere. So it's creating two bubbles, one on top, one on the bottom. If it created one, we would have already been done. The problem is it's creating two. And now you have to pop fields between the two in order to get it to lift. Does that make sense? So
Yes.
it would be better with a hole in the plate in the center, no center plate. You know what I mean? With the rotating things on the outside of a Tesla coil would have been so much simpler. You know what I mean? But
So it's not creating any time dilation. Its current
it
state.
could in the disc, but they're not strong enough. They don't have the right frequency on them and everything. So it's probably not.
It would be
It's
kind of
more
cool,
of
like if you can, and then you turn this thing on for like I don't know a day or two, and then you go outside into the world, and like you're ahead of everybody. Like a day or
It's
two.
a time pausing machine.
not the way this one is. It doesn't have the right geometry to it to do it.
You turn it on, pause time for 2 days, and
I have basically a field generator is what the Graviflyer is. It's a field generator. And basically it just happens to make lift if you know how. That's it. But its total job, I can tell you this as a fact, it's a field generator. Okay? It generates a Tesla coil field because you're rotating the Tesla coil. At that point, if you put it on the disc that rotate, it'll create a field. And then if you put a high voltage on it, it'll push that field. Okay. If you put the Tesla coil to the center plate, it'll hold in a high voltage field or static field. So it's basically a field generator.
a Tesla field, but not a magnetic field or whatever.
Oh, it has more magnetics on the Tesla coil than it does on the static, so it holds it in.
So if it was really strong enough, it could create a warp field. It could, right or no?
Oh, I could create one big field and I can have it hold on to a lot of static electricity. But it would have been much easier just to create an outside shell and produce it on that spun. Would have been so much easier. Yeah,
the Heaviside. And if you look back in history at Oliver Heaviside, man, did academia attack him. Oh my God. Like literally, they made the poor guy go nuts. And they suppressed him and everything. It's one guy to really look into is Oliver Heaviside.
I'll have to take a look at it. Yeah, I've heard the name.
Yeah, Oliver Heaviside.
Yeah, but
they did a number on him.
It would be so much easier. Look, I could put a piece of paper around the whole thing and get much more effect than I ever could leaving it wide open like this. So, because then I can magnetize it, I can then create charge, I can move it anywhere I wanted to, and it wouldn't be a problem. It's wide open, and it has to have an enclosure, and that's like one of the main failures of it.
Like say like a glass dome around it, would that work?
Well, I don't know if glass, but like
or
I said,
even plastic, plastic sphere.
If you put plastic around it like a balloon, then the inside would heat up, and if the balloon can take it, it would lift up. Because it'd
Really?
be
How about
basically a
how
hot
about
air
two
balloon at
crystal
that point.
bowls?
You're
How
putting so
about
much
two
energy
crystal?
into it.
Mm. Now,
How about
if
two
you use,
crystal
say,
bowls?
actually, I was thinking something more like a dielectric. Now, apparently, polylactic acid, which they call PLA for 3D printing, it's one of the most common materials that they use for 3D printing. If you printed that and put that around your graviflyer, I don't think it would heat up because it's a dielectric.
Well,
Actually, it's a very good dielectric.
if I put it, it needs to hold it. So the PLA won't hold the charge. So I need it to hold it. So I need to add paper. So paper mache the outside, and we might
Yeah.
be all right.
Paper, actually, what you might want to use is tar, paraffin wax or beeswax, and tin foil. You can use tin foil as well. That's what Townsend Brown was using making his lifters. So he was basically making like a dome-shaped capacitor. Is what it is. That holds electrostatic charge.
Well, it
So,
depends on the amount you want to hold it for, how quickly to just charge
well,
the charges. That you have to take that in consideration. Because styrofoam holds the charge for a long time, but it also takes longer to charge. Where
yeah,
paper charges and discharges almost immediately.
right. So that's why he was using the tar, and he was using beeswax or paraffin wax. Now, uh, he was pumping in over 400,000 volts in some of the devices, actually some up to 4 million volts.
Yeah, that's
So
insane. That's a lot.
yeah, that's a
Well, what
lot of
happened if you
charge.
do
Sounds
the
like
Faraday
density
shielding
determines the
cloth?
charge rate.
Yeah, you're building a electrostatic condenser is what you're making. It holds that charge.
Yeah.
So
Would
maybe
the
looking.
Faraday cloth work? Like there's a cloth. It's like a
No, that
Faraday cage.
neutralizes. No, that
Okay.
neutralizes. Yeah, you want
Okay.
something to hold that charge in. So even mica, if you were to get some kind of material that has mica in it, that's like a sheet or a
Is
foil.
that the stuff?
If it
Is
has
that the stuff they use for the cooking stuff? Like
capacitors.
that, that
Yeah,
black
you
stuff?
can.
It's an insulator.
Yeah, well,
Okay.
it's an insulator. They use it for ceramic capacitors. It's mica. It comes from the ground. It's actually a rock, right? A very very porous rock. It's very brittle. It flakes off. It's really a unique type of rock. I've actually held some in my hand. It's pretty
They
interesting.
use them to insulate transistors against heat sinks.
Yep. So
Mica. Is that what that's the
Yep.
one you were talking about,
Yep.
Mica? It's
Yep.
underneath the pyramid in Mexico, right? They found
Yes, it is.
Maybe the
lot of-
pyramid is a transistor and it's the Earth is the heat sink. Maybe they're insulating against the Earth with it.
Yep.
Strange.
Yeah, because
They were doing it.
it's good at insulator. Yes.
Yeah, it holds electrostatic charge. So, say if a lightning bolt were to hit that pyramid, guess what's going to absorb all that energy? The mica in the ground.
Or the pyramid.
Well, it'll go through the pyramid. If the pyramid's made of, say, so
There's this
yeah, you could
product
use
called
that.
Flex Seal. There's this product called like Flex Seal. It's like a rubbery black thing. You could, if you have something like that's broken or cracked, but it's like it comes in different colors. But I think that would be a very good insulator for what you're talking about. Like, I I don't know if you've seen the commercials
seen it.
for it. It's called, yeah. I think that stuff would work really well.
Yeah.
Let's check that out. Because it would be so much easier just to build a whole separate thing that's done right.
Yeah.
Yeah, like Townsend Brown, he was using tinfoil, he was using tar, he was using paraffin wax or beeswax,
Wouldn't you want
materials like
something
that.
light? Like light, something
Wait,
is it
wait,
heavy?
Well,
Like
it wouldn't really matter.
weight?
It wouldn't matter because his device was actually creating a lot of lift for the amount of voltage.
Yeah, but you're also
And-
creating a field bubble that makes it separate from the Earth itself.
Right.
So it would be like the weight it would be on the moon versus the weight
Yeah.
that it is here. It wouldn't really, matter because you're creating that field bubble.
Well, here, going back to
Right.
magnetic field bending light. Well, if you can bend light with a magnetic field, it's not far off to think that you can bend gravity.
Well, see, that's what I was asking, because if I can spin that Tesla coil, you know what I mean,
Right.
on that plate,
Mhm.
I want to
Yeah.
put up a laser to it, and I want to see if it moves it at all. You know what I mean?
Oh,
All you got to do
If
is
it
bend
changes-
gravity around the craft, not
Yeah.
through it.
I mean, I just want to see what it does. If it can just bend just a little bit on the little edge of it, then,
Deflect gravity, not necessarily bend it, but
but I
deflect
can find a way to see it.
yeah, with the laser light. Yeah,
I don't think these craft are
absolutely.
canceling gravity or doing anything such of a thing. I think they're just superpositioning themselves in the gravity field by deflecting it around the craft.
Yeah, but it makes a lot of sense when you look at Alexi's infrared on the gravity flyer. You see the field; it's clear as day. It's right there.
Of course,
So
it's going to be
something
on
in
the
that
shell of the
light
craft
is
because
showing-
it's deflected.
Yeah, something in that light's showing it. So, somehow
If
he
you see
found
light
the
on the
exact way
craft,
to
if
see
you
it.
see light or coronas on the craft, that means that and it's obviously anti-gravitic. That must mean the gravity is not penetrating through the matter of the craft and not
Right.
affecting the craft. It's going around the
Exactly.
craft,
That's right. It's
creating that
canceling it out.
corona. The gravity field is creating that
So-
corona.
Yeah. So
Nathan,
you
but
got to
you're right.
find.
It would be nice to see it. It would be fun to
Because
actually
you could
visually
use
see
a
it.
magnetic
visually,
field
yeah.
to bend light. Stars, magnetic fields do that. You're bending light with a magnetic field. It's not far away to bend gravity with a magnetic field.
Well, yeah, because you're canceling, creating that field. Gravity cannot penetrate it as it were penetrating, a
And
regular.
it makes
solid
sense now how
object.
these craft are able to disappear
You're
because they
deflecting,
already
you're-
bend gravity. Now
Well,
they
you're
can bend light, too.
deflecting. Yeah, I think it's a deflection principle, and not so much canceling it out. It's a deflection.
Right.
of gravity.
It's not canceling gravity, right? It's deflecting it around.
Right.
It's a lot less energy to do that. If you had to cancel even the weakest force in the universe, it's still a lot of energy to cancel the weakest force in the universe, in my opinion. Because it may be a weak force, but it's everywhere. It's grand. It's the grand force.
Yeah, but
Well,
that's
yeah,
right.
because
You don't want to go against that, but you can have it go around you a lot easier and cheaper on your own energy by
Yeah.
deflection.
see, the problem is nobody's been able to establish
Magnetic field.
not the magnetic field, the constant of the zero, what the zero is in space, because the Earth is moving through space, over 200,000 kilometers per hour. We're traveling around the sun. Our sun's traveling through, the cosmos at a huge velocity speed. So therefore, even though gravity is the weakest force we know of, it has a profound force on any matter because we're traveling so fast through space. We haven't been able to establish a ground point, a zero. You see what I'm saying?
Yeah,
So,
there's no absolute grid. That's what you're saying.
Right.
Everything is
There is no absolute zero.
Yeah.
What is that anyway? What does that mean? A balance point?
No, a zero stop point in space because we're moving through
Does that
space.
mean no
right
motion or a point where there's no
zero-
motion?
now. Right. Exactly.
I don't
The-
think that
No
exists,
motion.
Mike. That doesn't exist.
The 0 point is where the most significant mass in the most important mass in the universe is. It will define where
Okay.
everything else is rotating around.
If you look at it like that,
Right.
that might exist.
Yes.
But if that doesn't exist, if there's two of those objects, the same size, the biggest objects in the universe, and if there's two of them, then there's no such thing as
It's
balance.
like it's also too like with the speed of light, kind of on the different side.
Even though
Like
they're the same
speed of
size.
light- like say like the speed of light, Eric Dollard calls it an arbitrary constant because the speed of light is not constant. So therefore, it's an arbitrary constant because the speed of light varies. It's not the continuous speed. Other things will influence the speed of light to slow it down, speed it up, whatever. So, he says that regular mainstream science just uses that as a benchmark when
For
it actually, for, speed of light, to calculate speed going
oh,
through space. Where he's saying,
1
how can
second
you
equals.
use? He says, why? How can you use that if it's arbitrary?
how
can't.
can you even
It's always a
benchmark
lie.
it?
Yeah, exactly.
It's just assuming that there's no particles, no nothing, and like complete like emptiness, and per second
So
would equal like 200 something, 3 I think, right?
okay,
The speed of light.
I have a good answer for Mike to explain what I'm talking about. Zero movement in space. So right now I'm moving through space. The cell phone's moving through space over 200,000 kilometers a second around the sun, and the sun's moving. So in actual fact, this cell phone here has a tremendous amount of energy in it. Now, what happens if I take the cell phone and I throw it off the train? This cell phone's gonna make a hell of a boom when it stops on the ground. That's what I'm after. Where is zero? See what I'm
Well,
getting
it's not where it hit the ground. Zero's not there either.
But that's
Yeah, but
what
the ground is relative also.
right. So
I mean, you have to find perfect
we're
balance, and even then, and that gives you zero when you find balance, and that is created by two weights.
right,
So,
equilibrium, right?
right, and let's say, like Phil said, there is this biggest planet in the universe that creates a place where there is no motion, which you can do that if you're the biggest planet in the universe. You're
Yeah,
the
and
source of
that's the whole
gravity. You are the
right.
source of gravity. You are not moving.
No, you are moving through
No,
space.
not if you're the biggest planet in the universe. You are the source of gravity.
Exactly.
You are
Yeah,
not
you got
moving.
it right.
Everything else is.
If you're the biggest
If
mass
you
of
have
the
the most
universe,
mass,
you cannot move and you
if your
cannot
planet
rotate as
is the
well.
most mass, or whatever,
The
whatever
biggest
star,
mass
or whatever, the most mass.
the biggest mass cannot move and cannot rotate as well.
The
Yeah, but it's
biggest
not
mass
mass, it's
within a
density.
certain area of space. The biggest mass, because you have,
Yeah, but it doesn't have to be mass. It just has to be dense, completely dense.
density. Well, then you get closer to black hole
It
formation.
has to do with the atomic weight of something. It has to be higher in that, not necessarily the size. The mass,
I mean,
the size doesn't
we're
matter.
heading in the direction of suggesting that black holes are the source of gravity.
But
Well,
they
you'll
move.
never know. We won't know until we
Or
get there, right?
Not if
Yeah.
they're the greatest mass in the universe. Not if there's if there's one black hole that's bigger than all the others, that one is not moving.
Yeah.
Assuming
Yeah,
it's the biggest thing in the universe and this is the only universe.
And
That's
even light can escape it. So
you know
yeah,
it goes
it's
on and
a
on.
pretty
See,
interesting topic.
that was the problem with
So to find
Newton.
zero, Mike, you got to find the thing with the most mass in all of the cosmoses that exist.
Yeah,
And we probably are in a bubble multiverse. So I think the
And
universe
likely
is
this, if
much
you find
bigger
that
than we would
mass,
think.
it's in the center of everything, and
Yeah.
everything's
oh, we got Ben on here. Ben,
But I
are you
think
there?
zero exists in
Hey,
everywhere. I think zero exists everywhere because in between the translation of one momentum
everybody.
or whatever you want to call it to the next, you have a balance point, and that's where the zero's found. In between the translation from one momentum to the next, in the middle there is balance of that transmission,
right.
and that's
And
why I
that's
think
what
there's zero everywhere. But it's not. What's the word you used earlier? It's not.
Arbitrary constant.
Right. It's just like the light, I guess. Maybe.
Right.
you'd
Yeah,
have
just
to
speed of
create
light
an
varies.
artificial 0 point. It's not.
Isn't 0 point the singularity?
It's only
Also?
constant in between each transmission of momentum, in the
Yeah,
center
but I
of
don't
that
think it's
transmission
everywhere.
of the momentum.
I don't believe that at all. I don't believe it's
Well, it's
everywhere.
constant for that transmission only, not
No.
the next transmission.
You have to create a 0 point.
Well, each balance between transmission of momentums, it has to be a center point of that momentum transmission has to be balanced for the transmission to
It's
happen.
why some cultures never use the 0; they always use the 1 first. There's a difference. It has to be an artificial 0 point. Unless you get to the 0 point in the center of everything. So otherwise, you just create an artificial one.
I don't know zero. I don't know zero. I don't know zero is the same thing as balance.
Equals does not make a 0 point.
I think it's more the equal sign we're talking about here, not the 0 or the 1.
Okay, well,
balance.
In my head, I'm hearing 0 point, and I'm thinking the center.
Perfect balance.
Yeah.
Perfect balance is 0.
Everything is neutral at the 0 point.
There is no imbalances. Everything is in balance. There's no imbalance. It's in
self-stable.
No,
self-stable.
I think it's completely neutral. No,
and you got momentum happening everywhere. And in between the transmission of whatever to the next of that momentum, there's got to be a balance point.
Right. We're all describing.
Yeah, there's equals, but it's not a 0 point.
There's
balance,
well, that's what I think. Yes. That's what I'm saying. That's what I think. The zero. Maybe I'm wrong. I just contradicted myself. You're right.
I know exactly what you're saying, but I disagree with the.
It's equals, not 0. It's the equal sign, not the 0.
It's equals. There you go.
Right.
0 point something totally different.
Right. You're right.
So you're saying it's the equals what?
But it also sounds like 0. Sounds like balance.
So basically, if you want to pull,
+1 would be the outer section of the vortex of one side, and -1 would be the other.
There you
side
go.
No, but
that's 0. But nonetheless, that 0 is in the balanced position.
No, I'm not disagreeing with that, Mike. Not at all. I'm just saying it's not everywhere, and you're not creating 0 points everywhere. That's all I'm saying.
Think about it.
Between two momentum points, it's the same thing as the black hole.
So that's
think about it.
0 point.
I think I got
momentum transmission.
I think I got it figured out. Think about it. If you consider gravity to be a superimposed force, so you have the gravity of the Earth, the gravity of the Sun, the gravity of the galaxy, the gravity of the galaxy cluster, the gravity of the galaxy supercluster, and the galaxy of the gravity of the universe. These are all adding up, and these are all layers of energy. But what tells us that there's nothing greater than another layer of gravity that is greater than the universe? Can you imagine all the energy that we would be in? All the energy generated by the bubble multiverse, the gravity generated by all that.
Yeah, it's infinite.
There's so much energy, in fact, that life had to be formed.
Maybe that's what defines the relative gravity-magnetic permeability and the cosmological microwave background, if you want, because it's some sort of layer of energy that comes out of nowhere, but it's not coming out of nowhere. It's actually the gravity layer of the bubble multiverse. That's the gravity generated by other universes around us.
Right, so but each gravity. I mean, is there only one? There's only one gravity field, or I mean, each mass of matter has its own field, though. You know.
Yeah, it's all layers of gravity or layers of energy, if you want.
Right. I don't think it's one field. I think they're all, like Phil said, it's not one gravity from one place. Every mass is generating a certain amount of gravity.
A layer of gravity energy.
So like when
and they're all radiating outwards, system, the gravity.
Yeah.
Like we have Andromeda and inwards. Our galaxy, the Milky Way. They're supposed to be at one point they're gonna merge. So could you say that one has more gravity pull on the other just by the mass? because one is bigger than
Yeah.
the other.
Of course.
Okay.
Yeah.
There's
Okay.
one
So
field, one.
I mean,
Right. Exactly. The one
So
north,
that
one
means
magnet stronger than the other.
so that means
Right.
the
So
greater the mass, the more
Mhm.
gravity pull
We
right.
see
would
that
have.
happen
So
anyway.
So
And,
you know
astrologically.
they've already proven this. You know, the weight that we weigh here on the Earth, if you go to the moon, you only weigh 1/3 of the weight that you do on the moon, because the moon's a lot smaller than our planet. So smaller mass, smaller gravitational forces.
I think the moon pulls its gravity from us on the Earth.
Probably does. Probably does.
I don't believe it has its own gravity per se. It has gravity from the Earth
Yeah,
Could
because
be,
it
yeah.
doesn't go
because it
around
doesn't
by
spin.
itself. It doesn't spin
Mm.
itself. It just
Assuming it's
it faces one
actually
side.
a moon, not a hologram, it would be held on to the Earth by. It would be held on by the Earth. Yeah. It has mass. Assuming
You
it
live
has
on flat Earth.
mass.
Can I interest you in a canoe for that? I mean,
I have a canoe already. Had it for 30 years.
Yeah. So say say that Jupiter was a solid mass. Could you imagine how much we would weigh on Jupiter?
Ooh.
Probably.
oh yeah.
You know, we probably weigh in the tons.
Well, it's like Venus spins. You know what I mean? Enormously
Mm.
fast, and they crush everything on the surface with
Yeah.
the speed that. If you just put a moon out there and slow it down and pull some of that away, you can get it to slow down, and then it wouldn't crush people so much. You'd be able to
Our
build
whole-
a tidal force in the center.
Yeah, probably
Our whole
triple your
biology
weight.
would be different. Our whole biology
Oh
would be
God, yeah.
different.
Well,
Yeah, like-
some actually to the point where it probably would kill us.
Yeah, if you landed on Venus, you'd be dead.
I
There's no
can't wait for
question.
us to land on the moon again. That way I'll know for sure it's real.
Did you
Well,
think
why
Earth
did we
had
stop going there on the moon?
I mean, last time they landed on there, I wasn't born yet, and that turned out to be somewhat of a lie.
Mike, we're all gonna go to the moon and
I
find
mean,
out
I'm
what
thinking
Let's
exactly
like
is
the
on
dinosaur
there.
age.
let's decant the lie and go back. We got the money to do it. Let's do it.
Yeah, Mike, we're all gonna take the Graviflyer to the moon. How about that?
Of course, that'd be the first
Yeah.
place anybody goes.
Yeah.
So
gonna
far,
take- I'm
nobody's
gonna
come back from there and say, "Hey, here's a moon rock." Other
I
than
know,
the,
no, it's
the one rock
it's
they said is a
frustrating.
moon rock.
It's frustrating, right? But we'll find out. We'll find out. We'll do
By
some
now,
independent research.
there should have been hundreds of people on this planet that were able to fund their own travel to the moon and bring back souvenirs.
Yeah,
and-
and in
Dude,
NASA,
You would know a friend that
conveniently-
knows a friend that saw
somehow-
these souvenirs by now.
Somehow NASA lost the technology to go back to the moon. They don't remember how they did it.
That's you know what, they had a NASA engineer actually admit on film that we haven't got through the Van Allen belt.
Right.
If a human
I-
goes
I
through
saw
the
that. They've
And
admitted
that's
it a
human
past the
couple
goes-
moon.
times.
The moon is
They've
past
admitted
that.
it a couple times on their live streams.
right, they've admitted we have not been able to break through the barrier of the Van Allen belt. If you do,
Good
you're
point.
dead.
And then
What
when
about
somebody
the
specifically
Voyager?
addresses that, like, well, they did it in 1969. I remember that alive, and they're like, well, we lost that technology. We don't know how they did it. That was their answer.
That
That's
is
ridiculous.
so pathetic.
I know.
That's
I know.
pathetic.
Then,
But I mean, that's what the students now are taught. Like, I guess, like we don't have that
It's
technology anymore. We don't know how they did it.
Oh my God, it's crazy.
What
There's
about the
cosmic
Voyager?
radiation.
And what about the Pioneers? And
what
what
about
That
about
Elon
thing
Musk?
is-
Hasn't he
That-
gone to the moon yet? No, he hasn't.
No,
He can't get caught past the
won't
Van
be
Allen
able
belt
to.
either.
that's right. You know how much lead
That-
shielding you would need to protect the human body? You would need several tons of lead shielding to protect.
And that's
you from
Starlink, by the
getting
way. That's
fried.
below the Van Allen belt, isn't it?
That's right. Yeah. It's,
Okay, question. What
It's a-
about the Voyager? Hasn't it passed, like
It doesn't matter. It's robotic. It's robotic. It's
Oh,
for
so we're talking
biological.
about, like, okay, okay,
You know,
biological.
if a biological person goes through the Van Allen belt, it's fried chicken.
And by the way, that's probably what destroyed the Voyager's communications getting through the Van Allen belt. That's why it
Well,
has
it could
problems
have. It's very
communicating
possible.
today.
It's very possible.
Just
But
didn't,
you know,
didn't show right away. It came up.
Personally, I'd rather send a
Heliopause.
machine. Personally, I'd rather send a machine up there and let that get fried first before you fry me.
Yeah, it's a radiation, right? Isn't it? It's like a
It's radiation.
right.
You know how much
Nuclear.
cosmic
Is it
radiation?
nuclear radiation or what kind of radiation is
Oh,
it?
it's everything, man.
Cosmic.
You know,
All the rays,
everything
huh?
is traveling.
It's the
Everything.
layer where all the space rays are combating with our field right there. I mean, that's all the radiation, right?
Yeah,
Right,
the
you got
cosmological microwave background is already
yeah,
And that
microwave.
and that layer has been forming for since the Earth was born. You know, just imagine how strong it is by now.
No, it's
And that's
actually
why
cooled
we
down now. Actually, it's like,
see.
yeah,
That's
it was
why
much
we.
stronger before.
Well, we don't know all
That's
these things for
you know
sure.
that's why we have a magnetic field around the Earth. It's there for a reason. It's to protect us from these
That Van
rays and
Allen layer,
you
that
know.
belt is not going to be its strength is not controlled by the magnetic field of the Earth. It's controlled by the rays coming in from space. The magnetic field from the Earth doesn't matter anymore because that field was generated a long time ago. So
Yeah.
now the fields coming from space are keeping it alive.
So if it's a belt, so it's just on a thin layer around our
Right.
solar system. Well, what
Yeah.
if they go up? Then there's no rocks up, or if they go down. Like if
It's
they choose a different,
it's
right?
yeah.
When I
It's getting through it.
when I
Yeah.
asked my because my friend is very skeptical and he's very smart when it comes to different areas of science, but he's very skeptical on this new science that we're studying. And when I asked him, well, how did they get past the Van Allen belt in 1969? And his answer was that they timed it in certain times or certain seasons or whatever. The Van Allen belt is thinner. Does that make any sense? I don't know if that's any kind of
Yeah, but
realistic
but
answer.
the thing
My
is, are you
question is,
going to
why did they
risk?
have to go through it?
Yeah, yeah, you still risk. Yeah, exactly. You're still taking a huge risk, and I don't know. Like
Yeah.
that was I still don't. I'm still not sold on the convent.
It's
like, the
not so
mainstream
much
story,
about,
but-
it's not so much about, look, if you're an astronaut and you got to go through a layer of just about every radiation known to man,
Mm.
do you expect to come back healthy? If you got to
Probably
go through that
not.
layer twice, I mean,
Yeah, I think there's going to
you're
be
not
some
going to come
damage.
back healthy going through it twice, maybe once if you're lucky.
Right. Yeah, because you
Yeah.
got to come back.
Even
on
with all the
return, you're right,
suiting
Mike.
and that suit is not going to stop that stuff.
Mm.
It's gonna change you in some way molecularly in your body, and it might not be very good.
I don't think that it's a risk that they would pour all this kind of money into to send all that money through a pile of radiation like that. And
What if
2
aliens
times.
were humans that changed?
Does the gold stop the radiation? The gold layer on the craft that they put for the shuttle?
You would
They use
need
it for the heat or whatever, but
yeah, you would need lead shielding. Anything that could stop X-rays and slow down neutrinos if that's even possible.
there's nothing that can stop that.
It's not easy. That's why I'm very skeptical on the moon landing.
And then there's the equipment inside there. All those rays, your whole craft is going to, every relay on there, you got to,
Yeah, it's
you
gonna
just a huge risk. Not just the
Yeah,
human life, but the craft, everything.
it's gonna be fried chicken.
So
It's
hold on.
not-
Are you
nothing
saying
is-
the Van Allen belt is stronger than the inside of the Earth, or is it supposed
It's-
to be weaker?
It's a barrier of harmful cosmic radiations that have been smacking into that barrier that has formed from our magnetic field back in the day, and it keeps getting stronger. It's like a field, thin layer field that's formed from two fields colliding, ours and spaces.
I don't know. It just sounds like if you want to keep the
Plus our
mice in
sun,
the maze, you got to put in thick walls. So it just sounds like they're kind of blowing smoke up, or you know what? Because it's supposed to get weaker as you go out. I don't quite buy their whole theory there.
Get weaker, the
There's some
fields.
holes in there.
fields from the Earth get weaker as they go out. They don't get stronger. So I
Right,
don't
but the Van Allen
understand.
belt is not the magnetic field of the Earth. It's nothing to
But
do
it's the
with it.
point where it collides with something else.
No, it's formed by our magnetic field colliding with the fields of space coming into our field,
I don't know.
and
I don't
that
know.
creates a layer of
I don't know that I
frequencies
buy all that. I don't
that
Okay,
know.
I have a question.
are
This is
balancing or
this is a
whatever, doing their
diagram.
thing, bouncing off each other.
Okay, this is the solar system like image. If this right here is the asteroid belt, right, and it wraps around, it comes after Mars, right after Mars, between Mars and Jupiter. Okay,
Yes.
there it's not a it's not like covering the sun. It's just it's a layer. But if you what if we like a rocket or whatever, a spaceship, and go over it? Why do we have to go through it? That's what I don't understand. Why are we? Why like why can't we just go over it to the other side? Why are we having to go through it?
Through what? Who said we had
Right?
to go through it?
Okay, this is what they're saying, that nobody has been through it.
Through a star?
No, through the asteroid belt.
Asteroid belt. Oh,
Yeah, that's the Van Allen belt, the
I
rock
thought it was a
debris.
radiation belt.
No, it's a rock debris. It's a like it's a
That's the
ring
asteroid
around.
belt. That's not the Van Allen belt. Van Allen belt would be
Van
between
Allen
Earth
belt
and
is
Moon.
a what?
Am I get me?
I thought the
Okay,
Van
never
Allen
mind then.
belt was a radiation layer.
Never
Top of
mind then. Never mind. I think
It's a
all right.
frequency layer full of
You're
radiation.
over in
I'm thinking.
Nibiru land. That's where between
I'm thinking
Jupiter
it's a
and
layer
Mars
of
Yeah,
rock.
she's
they have
talking about the
another
asteroid
planet.
belt.
Yeah,
I
Okay,
thought it
That's
was
different, right?
That's
I
called
thought
the
it was a
Kuiper
radiation
belt, by the
belt.
way. The Kuiper
It's not a
belt.
radiation.
Kuiper belt's further out.
Is it?
It's not
Well,
a radiation belt.
but by the way, earlier we were talking about the photon being deflected by the sun
Yes.
because the edge of one photon goes at a different speed than the edge of the other photon. Then that means if we calculate the deflection, if we observe the deflection of the photon, we could solve the dimension of the photon. You know what I mean? By if we reverse the process of calculating the deflection, the predicting the deflection of a photon, if we reverse that process, then we can predict the dimension of the photon. Well, while you guys were talking, I was thinking about that, and I'm gonna do the calculations, and I'll let you know next week. That's pretty interesting. I'm trying to link also the why an energy potential creates an acceleration. I still don't get it. Why why if you take out the space-time curvature out of your mind, and if you just see gravity as an energy potential, why are we being accelerated towards the center? And still trying to figure out, but I think it has to do at the atomic level and um, the difference in speed that similar to the photon we just talked about. So I'm a little bit fuzzy in my mind, but I'll clarify that and I'll come out with some mathematics for next week because I'm sure time dilation is responsible for acceleration. Time dilation in the energy potential will induce acceleration because the force is not coming out of nowhere. It comes out of it's being caused by something. So I think I think time dilation is responsible for creating the force or the acceleration. I'm not sure if I lost people here, but I'll clarify all this next week.
Phil, I think you have to think of it in terms of what's the incentive for an atom? Like for us human beings, how do we gain energy if we have incentive for something? We all, like get energy, momentum, and turn that thought into energy. What is the incentive for an atom to, you know, gain that momentum and transferring that inertial energy into motion? So you have to think, what would the atom be thinking in order for it to want, so something like that, along that lines.
Yeah, I think the atom is. I already explained the atomic forces in my paper, the strong and the weak atomic force, and that builds that creates the cohesion of the atom, uh, and
Right.
the this an atom is just a form of
The
energy.
strong would feed the weak force.
Yeah. So the time dilation is responsible for creating the strong and the weak atomic forces, and that explains the. It also explains why the electron doesn't crash into the nuclei. Um, it explains all that, and also explains why atoms are repelled from one to each other, one to each other. Yeah. Um, Even if the charges are the same, the charges of the nuclei are the same. So I'm able to explain all that. So that's cool. But an atom is just a form of energy. It's not like a ball of pool or something like that. People see an atom like a ball of pool.
Are
Uh,
all the atoms the same? Are they all universal? The same charge?
yeah, yeah. It's all the same thing.
The same
It's,
charge too?
no, no. The charge, you have
Different?
negative and positive charge, but
I mean,
um,
is two atoms have the same charge, or they have different charges?
um, well, the nuclei has the same charge. The electron has a different charge.
So basically, if you take two different atoms, is one having the same potential as the other, or they are different potentials?
Well,
Meaning,
I mean, if
because
it's
an atom it has the number of protons and electrons, the same
yeah,
number of protons and electrons. Both atoms have the same number, right? Same
yeah,
ratio of protons and electrons and everything. But one atom could be excited more than the other and be rotating faster than the other. So one would have more charge than the other, and you have a stronger atom and a weaker atom, right? Right?
because of the rotation.
Yeah,
Yeah, that's an interesting question. Um,
and there would be your strong and your weak force. So a stronger rotating atom would deposit its rotations to a slower rotating atom, and that cycle would continue on. But somewhere in the beginning, there's atoms spinning faster than all of them. You know,
yeah, but I'll think about that later. But my
like
point is,
the wheel work of nature. The wheel.
my point is, an atom is just it's just a virtual particle. A virtual particle is energy. That's what it is. And energy is it's not like a pool of a ball of pool that solid ball that clashes with other balls
I mean,
and
is the
are
energy
being
density of
bounced.
each atom the same, or is it different?
The nuclei, yeah, it's the same, but the nuclei is not the most, is by far not the smallest particle. The smallest particle is the quark, and the atomic
Atoms
force.
have quarks.
Yeah, the atomic force is the gluons that connects the quarks. I'm able to
Oh,
explain that.
right. The
Uh,
atomic force creates the quark, right?
yeah, so yeah, and you have the atomic force and all that.
So the
And
atoms have byproducts
Pions
like quarks and neutrinos and stuff.
yeah,
and
but
and pions.
my point is it's all made of virtual particle, which is energy, and energy are being are being repelled. They're bouncing. They're bouncing like balls of pool because of the time dilation. The time dilation has an opposite effect. As we're at really close distance, it's gonna flip over the charge. So if you have a proton and an electron, they're going to be attracted, but at very close distance, they're going to be repelled because of the time dilation. I already calculated that.
Because of the distance between them creates a time dilation.
Yeah, there's always time dilation, but
Right, because
time
you have
dilation
distance, right?
makes
So that's
effect.
time.
It makes a weird effect at atomic distances, and it reverses the effect of the charge.
And when
It
they're close
reverses.
together, they repel.
Yeah, instead of attracting at very very short distances, they repel, and yeah, so that's what it is. An atom is just it's not like a ball of pool. It's a form of virtual particle or energy. That's all it is. It's there's no conversion of mass into energy. It's already energy, It's already dense energy. And when you convert it, and same thing with a charge. Charge is a form of energy as well. So that's all it
So
is.
your charge, you give thanks to having charged, you give that thanks to the atom.
Yeah, mass and the charge is
So your charge
it's all
comes from the
energy.
atom.
It's all you can convert the mass into a charge, and so that means we can create a pretty damn powerful nuclear bomb if we could convert uh, electricity, the charge of a lightning bolt into energy. Then it's gonna create a pretty powerful nuclear bomb because a charge is a form of energy as well. That's what that's I think that's what the missing link is.
Instead of
The
using energy to bomb Nagasaki, we used matter.
Yeah, instead of using matter, we use a charge, the energy of a charge, or
Well,
multiple
what?
charges, obviously.
Well, what good is using energy to create a bomb if you're trying to make gravity with it or defeat gravity? Then the bomb result is not helping. It's just destroying your lab.
Yeah,
you
that,
got
that's, a,
you
that's
got to
a,
get around the converting energy into that state where it just blows things up. How do you store it instead and use it for other things?
yeah, that's a practical problem right there.
Mm.
But
Interesting. Well, guys,
Using
we're
it
at
for
the
thrust.
2 hour mark. Yeah, we're at the 2 hour mark. I got to get up early tomorrow. I got to get some repairs done to the car. Everybody, thanks a lot for joining us. It's our Free Energy Friday, League of Extraordinary Inventors. We'll go live again. I believe next weekend's the long weekend, isn't it?
is it?
Maybe.
Memorial Day or something?
I think so. It's Labor Day
Day.
weekend, I believe.
Labor Day.
Yeah,
Is it?
so
Oh, yeah.
maybe we will. Yeah, so what we might do is skip next week, and then the week after Labor Day weekend, we'll do another live show.
What is that
So-
noise, man?
What was that? That yelling?
I think that's my kids playing upstairs.
Uh,
Maybe. Sorry.
Somebody
The
lost
scream
that
of-
Fortnite.
The scream of death.
But, man, like they're obsessed with Roblox, Minecraft, and some other weird
Oh.
game. Yeah, like it's just, they're obsessed with these games.
Oh, real quick before we end the stream, I wanted to let everybody know
Yeah.
I am doing a pre-workshop. I got the coil from Nathan, very generous Nathan, thank you. And we're going to be going over materials list and how to actually assemble the coil frame this Sunday at 3 o'clock Eastern Standard Time.
Cool. That'll be cool.
Yeah.
So
Very cool.
we'll do our next show. I guess September 6th. It's going to be a week Friday. So,
Okay, so I'll be sure to have the results of my experiment by then, if it's in 2 weeks.
yeah, I think
Yeah,
we'll
that'd
do
be
that.
really cool.
So everybody, thanks a lot for coming on the show tonight. It was a really interesting show, a little bit different than what we normally talk about, but still really cool stuff. Yeah, any updates or whatever, you can tune into Faraday Research. Don't forget to check out Old Man Builds and also Benefactors YouTube channel. Mike does. And Philip will hear about his results in 2 weeks. Everybody have a great night. Have a great
All
weekend.
right.
See you
Thank
guys.
you.
Thank
Bye,
you.
everyone.
Thanks, guys.
You live
Good
long
night.
and prosper.
Bye, guys.
Yeah.
Thank you.
Take care. Bye.
Live long and prosper.
Bye.
Remember, if you like my content, please consider subscribing and hitting the like button on my videos. Comments and any form of engagement dramatically help us break through the YouTube algorithm. I also have a website with research on the Thunderstorm engine, plasmoid technology, and do-it-yourself guides for Malcolm Bendel's retrofit, courtesy of Jordan from Alchemical Science and the Martin Fleischmann Memorial Project. Check out my store for exclusive merchandise along with our forum, where you can post questions, share videos, and join in the community to help destigmatize all forms of forbidden knowledge. Don't forget to check out Jordan's channel Alchemical Science and Bob Greenier from the Martin Fleischmann Memorial Project YouTube channel. They're on the cutting edge of cold fusion technology. More updates on that coming soon. Stay tuned for a new episode of The Social Situation, where I take you on a deep dive into the corrupt world of